So I wanted to talk about the St. Petersburg paradox because this is one of my favorite paradoxes in mathematical statistics. The idea of it centers around the notion of an expected value. So for most people, expected value is essentially what the name suggests. It is how much you expect something to be. So for example, if you were to, let's say, flip a coin 10 times, how many times do you expect to get heads? Well, that's just 5 times, so about half the times, because you're equally likely to get a head or a tail. But it turns out that expected value can also be useful for things such as, for example, gambling. So let's say you were making a bet that costs $5. And now let's say in this bet, there's a 20% chance that you win $20. And there's an 80% chance that you win nothing. Well, then what's the expected value in this case? That's just, we know that 1 in every 5 try will win $20. And then the rest of the time, so the rest of the time we make nothing. And so that just averages out to $4. And so that tells you that you probably shouldn't take this bet because the amount of money you expect to win, well, that's much less than how much you're paying to make the bet. Okay, but as it turns out, sometimes the expected value can be a very odd measurement. So this is where the St. Petersburg paradox comes in. So consider this following bet. So suppose you were to flip a coin. And then you keep flipping until you get tails. So let's say you flipped heads, 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 and then you got tails. Okay? So then you count how many times you got heads. And we're going to call that number n. And then the amount of money you win, well, that's just 2 to the power of n, right? So if you flip a tail right away, well, then you flipped 0 heads, so that's 2 to the 0, which is 1. If you flip the 1 head, that's 2 to the 1, which is 2, and then 4, 8, 16, 32, so on and so forth. Okay, so the question is, what's the expected value of this bet? So how much money do you expect to win if you were to make this bet? So to do that, what we need to know how much money we can win and the probability of winning that much money. So in the worst case scenario, you get unlucky and you just flip a tail right away. In this case, so flip. In this case, you just win $1. And, well, there's a 1 in 2 chance of flipping a tail on your first try. Now, the second outcome is that you can flip a head, but then flip a tail on your second flip. So in this case, you'll flip 1 head, so you win $2. And the chance of this happening, well, it's 1 in 2 chance of flipping the head, and a 1 in 2 chance of flipping the tail. So that's just 1 in 4. The third outcome is you flip 2 heads and then a tail. So in this case, you win $4, and then you can probably see the pattern at this point. The chance of this happening is 1 in 8. The fourth scenario, is 3 heads, you win $8, and this is a 1 in 16 chance. And you do this, so on and so forth. So since there's a 1 in 2 chance of winning $1, this contributes to an expected winning of $0.50. You have a 1 in 4 chance of winning $2. So 1 over 4 times 2, well, that's, again, 1/2. You have a 1 in 8 chance of winning $4. So 1 in 8 times 4, it's again 1/2. And you can probably guess at this point, it's all going to be 1/2 all the way down. So then your expected amount of money that you win from this, well, that's just 1/2 plus 1/2 plus 1/2 plus 1/2 all the way down. And that's infinity. Now, at first glance, this seems to be, a paradox because, well, if you think about it, you can never win infinitely many money because you're eventually going to flip a tail, right? Like, there's no scenario where will you ever actually win this much. So if you can never win this much, how can the expected amount that you win be this number? Well, the neat thing about math is that whenever something works out to be extremely absurd or unreasonable, oftentimes it's not a problem with our theory, but with our understanding or interpretation of what the numbers mean. So here, we're not actually saying that you can make infinite money by doing this bet. What we're saying is that on average, the amount of money that you win if you were to repeat this bet over and over and over and over again is infinity. But that still doesn't seem to make a lot of sense. So let's take a look at what's going on here. So if someone told you, well, the expected amount of money is 1/2, would you believe that? Well, probably not, right? Because if you look back here, the least amount of money you can win is $1. So there's no chance that you would just make 1/2. You'll always make more than that. Similarly, it's probably going to be greater than $1, right? Because, well, again, that's the least amount you can win. What about $2? So it's possible that you won't make $2 from this bet, right? There's a chance that you might get super unlucky and just keep flipping tails. But the chance of you flipping tails infinitely many times is, well, it's very, very, very unlikely, because if you've ever flipped the coin before, eventually you're going to get heads and tails and some mixture of both. So if we were to keep flipping the coin over and over and over and over again, more likely than not, you're eventually going to flip more than one or more heads, in which case you'll make a lot more than $1 and a lot more than $2. So on average, if you were to keep repeating this experiment, you would probably make more than $2 on average. What about $4? Well, that's also true, right? Because even though it's possible that you make less than $2, you might have this one really lucky run where you just keep flipping heads, like, I don't know, 6 times or something. And then that's instantly $64, which if you were to average that out with all the ones and twos, well, that's going to raise the average by a lot. But obviously, the higher that this number is, the more trials it's going to take before you actually win this much. So essentially what this infinity is saying, well, it's saying that if you were to make this bet over and over and over again, infinitely many times, if you had, infinite time in the world, then the amount of money that you would win on average, well, it's just going to keep going up. So there's no limit to how high you can get, which is why it's infinity. But obviously, in real life, this can never happen because time is a limited commodity. So from a practical sense, this does not make sense, but it is a theoretical explanation for how these type of values even show up in math in the first place.